Hi everyone, my name is Johnny Lim from Wiwin. In this talk, I'm going to talk about coreboot LinuxBoot development on OCP server Delta Lake and OCP OSF checklist. So this is my agenda. First, I'm going to talk about Wiwin's OSF journey. Here, OSF represents Open System Firmware. It's an OCP project. And then I'll talk about OCP OSF project and OSF checklist. And then OSF Builder for coreboot LinuxBoot. It's an open source tool for you to configure and download software components and build a firmware image. And then I'll talk about how we implement our firmware configuration for coreboot LinuxBoot. And then Delta Lake OSF features, and then the benefits of open system firmware, and finally call to action. So here's Wiwin's OSF journey. Starting from 2019, we work on OCP Mono Lake. It's a joint collaboration with Meta, Intel, and Elements. At that time, we developed features for IPMI, SM BIOS, ACPI, and board configurations. And we continue our works to 2020. We work on OCP Tiago Pass and OCP Delta Lake. In OCP 2020, about coreboot LinuxBoot development, Meta developed ROS features and Elements developed security features, and we also did some performance optimization. And we continue our work to 2021 on OCP Delta Lake, and we submitted OCP OSF checklist for Delta Lake, and it just got OCP accepted. The overall features have reached pre-production readiness. In 2022, we have been working on Intel Sapphire Rapids. CXL memory device support has been added, and we target for production readiness. So this is OCP Delta Lake. It's a single socket server designed based on the third generation Intel's Xeon scalable processors, which is referred to as Delta Lake one socket server. OCP Delta Lake server is a component of multi-node server system Yosemite v3. So on the left picture, it's a Delta Lake single socket server node. In the middle, it's a single sled containing 4 server nodes. On the right, it's a Yosemite v3 system containing 3 sleds. So OCP Open System Firmware project, here's the link to the project. The main goal is to let the owner be able to firmware, but not all firmware components need to be open source. Public redistributable binary blobs are accepted. For our case, it's Intel FSP, PCH Ignition firmware, and microcode are those binary blobs. Starting from March 2021, OCP accepted batch requires system supporting OSF. Wiwin Yosemite v3 has been accepted by OCP and got the OCP accepted badge, partly due to OSF support. So to get a OCP accepted, here's a link to the checklist and also the link to Delta Lake OSF checklist for your reference. Section 1.2 of the checklist lists the required artifacts we need to submit: firmware image, description of the firmware ownership model, top-level build script, documentation, test results, tool for user modification. I will introduce most of the items here. So section 3 of the checklist is ownership and reusability. For OCP Delta Lake, we use Intel CBNT. The OEM key and the CBNT security profile can be fused onto the PC edge. So for our customer, they have 3 options to choose from. A, customer could choose whether to fuse or not and how to fuse depending on the customer's thread model. Or B, customer could choose to use different profiles of Intel CBNT or to use coreboot's verified boot. Or C, if the Delta Lake was fused with other owner's OEM key, transfer of ownership is not possible. The next owner can use it only without Intel CBNT. Section 6, test regimes. The firmware must be able to do code and won't reboot to an OSI approved OS over 100 times. How to download and build. So this is the link to Delta Lake OCP OSF GitHub page. You can find most of the information there. So very straightforward. You just git clone the repo and execute, download, and build shell script. First, it will download Intel public blobs, including FSP, PCH ignition firmware, microcode, and then we'll download the toolchain, the coreboot, and LinuxBoot source code through OSF builder. And finally, you will trigger make to build the firmware image. Pretty straightforward. So this is OSF architecture at Meta. It's called coreboot LinuxBoot. So the left box represents the system firmware on the boot ROM. Coreboot and FSP do the core chipset initialization, and then it jumps to a Linux payload called LinuxBoot. It provides rich Linux utilities written in Go. And finally, you can boot the target OS through KZAC. The target OS can be booted either over network or from local storage. So OSF Builder, we use this open source tool to help you configure your software components. The core of OSF Builder is getDeps. It's an open source tool that written in Go that can help you JSON file. Supported components are coreboot, kernel, and initRandFS. So here's a link to an example of a QEMU JSON file. So from the left, the coreboot URLs, and the right is the toolchain, the cross GCC tarbos that define. You can configure those source code URLs and files toolchain URLs, so the tool can download the tools and trigger. It provides an example for QEMU, so we encourage you to try it out. Firmware configurations. So we use command line interface Euro shell for firmware configuration. The firmware configurations are stored in a BIOS flash region called VPD. As the firmware configuration are stored as key value pair. There's an open source Linux utility called VPD that can decode the key value pair. Read-only VPD is the flash region hosts the default values, and read-write VPD is the region hosts customized values. So the firmware would access read-write VPD region first, and then read-only VPD. Flash-ROM is a Linux open source Linux utility for BIOS flash region read-write. So from the picture, the firmware execute the VPD and execute calls flash-ROM to do the flash region read-write. Currently, we execute these two binaries in our firmware, but they might be implemented as Euro packages in the future. So CMOS clear to restore the firmware configuration back to default can be done by reformatting read-write VPD region. So the values will be used from the read-only VPD region. Here's the Euro commit for your reference. Firmware configuration. Here are more examples. The first link is the coreboot page to Delta Lake firmware configurations. The first example is boot order. We use system booter Euro package to describe boot interface. The first VPD variable boot 000 is set to value netboot using method DHCP IPv6. The next boot order is set to using local boot using grub. Another example is FSP log enable can be controlled by VPD variable FSP log enable being set to 0 or 1. VPD boot manager is a Euro command line utility for managing VPD variables. The usage are below. For example, get will print the variable value, set will set the variable value, and delete will delete the variable. Here's are the execution screenshots. The read is done by reading CCFS kernel interface, and write is done through executing VPD and flash ROM binaries. The first example is we get the value of FSP log enable, and it shows value 0. And the next example, we set it to value 1. From the screenshot, you can see it executes flash ROM binaries to do the job. Delta Lake OSF features. The link to Delta Lake OSF features, those are documented on the page. For example, system tables. Most of the SMBIOS ACPI tables are implemented, and BMC integration, IPMI handshaking, cell record generation, and IPMI dump. This is a Euro utility that's similar to Linux IPMI tool. And supported devices, including PCIe data drives, NIC card, and support OS booting methods, SSD, IPv4v6, and the security features. It supports Intel CBNT, converged, bootguard, and TST, and ROS features, and the performance tests we run. The performance test results are comparable with a proprietary UEFI solution. So the benefits of open system firmware. Number 1, system security and availability. Customer and the community can inspect, review, and validate the code. Number 2, engineering efficiency. It can leverage the help of open source community, such as feature development and bug fix. In our case, coreboot has a vibrant community. An active open source community is a very important factor to the success of an open source project. And number 3, time to market. Our customer can develop or customize their code and integrate with the rest of the solutions. For example, there could be some POC idea they want to test first. They can have their vendors and themselves try to develop as early as possible. And number 4, faster image update cycle, because it's less dependent on vendors to release the update. Finally, call to action. Please contribute to coreboot and LinuxBoot open source project, and please contact WeWin for purchasing Delta Lake, and please contact 9-Element Cybersecurity for Delta Lake OSF features development and professional support. Here's the link to OCP OSF Delta Lake and the contact information to 9-Element Cybersecurity and WeWin Yosemite v3 webpage. Here are references for first is OSF project and coreboot and LinuxBoot. Thank you.